The boarding chime. The first sound you'll hear after stepping onto the plane is a soft electronic chime, usually 1 or 2 tones, sometimes followed by a flight attendant's voice over the PA. That chime is the cabin call system, and it's how flight attendants signal each other and the cockpit. A single chime usually means a routine call between cabin crew. A double chime can mean the pilots are calling the cabin. A triple chime, on some airlines, signals an emergency or urgent message. Look at the small panel at the front of the cabin, and you'll see the call buttons crew members use to trigger these. Every airline has its own chime pattern, but the function is universal. Quiet, non-alarming communication that doesn't disturb passengers. The reason it's a chime and not a buzzer is intentional. Buzzers create stress. Chimes don't. The whirring under your feet. Right after pushback, you'll hear a low whirring sound coming from underneath the cabin floor. That's the hydraulic pumps spinning up. Almost everything on a commercial aircraft that moves, flaps, slats, landing gear, brakes, control surfaces, is operated by hydraulic pressure. 3 independent hydraulic systems run through the aircraft, each pressurized to around 3,000 psi by electric and engine-driven pumps. When you hear that whirring, the pumps are pressurizing the lines so the pilots can start moving control surfaces and steering the aircraft on the ground. According to Boeing technical specifications, a 777 hydraulic system can generate enough force to move surfaces against 90 metric tons of aerodynamic resistance. The sound is small. The system behind it is enormous. The engines spool up. Once the aircraft is being pushed back from the gate, the engines start. You'll hear a rising whine that builds slowly. That's the N1 fan, the giant fan at the front of the engine, beginning to rotate. The whine starts low because the fan is spinning at low RPM and rises as the engine accelerates toward idle thrust. On a modern high-bypass turbofan engine, the fan can spin at over 3,000 RPM at full power. Look at the engine on takeoff, and you'll see the fan disappear into a blur. That distinctive rising whine is one of the most recognizable sounds in aviation, and it's also the moment most anxious flyers tense up. There's nothing wrong. The engine is just waking up. The barking dog. On Airbus A320 family aircraft, you'll often hear a high-pitched barking sound during pushback and taxi. Short, repetitive, almost exactly like a small dog. That's the PTU, or Power Transfer Unit. The PTU equalizes pressure between the 2 main hydraulic systems on the aircraft. When pressure drops in one system, the PTU activates to transfer hydraulic fluid from the other side, and the rapid pulsing of fluid through the unit creates the barking sound. It only happens on Airbus aircraft because of how their hydraulic system is designed. Boeing's system equalizes differently and doesn't make the noise. Passengers regularly report this sound to flight attendants, convinced something is broken. Nothing is. The barking dog is just an Airbus working correctly. Airbus engineers know about it. Pilots know about it. They've all decided it's not worth redesigning a working system to silence it. The thump. As the aircraft starts moving forward on its own power, you'll often hear a single dull thump from below the cabin. That's the nose wheel passing over a runway expansion joint or a paint stripe at the gate exit. It's not mechanical. It's just the wheel hitting an uneven surface. The reason it sounds dramatic is that the nose gear is directly beneath the cockpit floor and the front rows of economy. Anyone sitting in row 1 through 5 is essentially sitting on top of the wheel. According to Boeing, the nose gear on a 737 carries roughly 8% of the aircraft's total weight, while the main gear under the wings carries the other 92%. The thump is loud because of proximity, not impact. Quick question. Have you ever been convinced something was wrong on a flight and it turned out to be normal? Drop it in the comments. And if you're finally getting why planes make all these noises, hit the like button. Now back to it. The takeoff roar. The takeoff roar is the loudest sound you'll experience inside the cabin during a normal flight. As the pilots push the throttles forward, the engines spool from idle thrust to full takeoff thrust within about 8 to 10 seconds. The sound builds from a low rumble to a steady, deep roar that vibrates the cabin walls. On a Boeing 777 with GE90 engines, full takeoff thrust generates over 110,000 pounds of force per engine, which translates to about 140 decibels at the engine itself. Inside the cabin, that's reduced to around 85 decibels, about the same as a hairdryer. The sound peaks during takeoff and then fades as the aircraft climbs, and the engines reduce to climb thrust. If you've ever wondered why takeoff feels louder than cruise, that's why. Takeoff is full power. Cruise is around 80% of full power. The clunk after takeoff. About 10 to 30 seconds after the wheels leave the runway, you'll hear a heavy, grinding clunk underneath the floor. That's the landing gear retracting. Hydraulic actuators pull the wheels up into the wheel wells in the fuselage. Doors close over them, and the gear locks into the up position. The grinding sound is the gear doors moving and the gear assembly rotating into place. On larger aircraft like the 777 or A350, the gear is so heavy that retraction takes 8 to 12 seconds. Look at the wing on takeoff, and you can sometimes see the gear doors closing. That clunk you hear afterward is the lock engaging. Without that lock, the gear could partially extend during flight, which is exactly the kind of sound a passenger doesn't want to hear at 35,000 feet. The chime change at altitude. About 10 minutes after takeoff, you'll hear two soft chimes from the PA system, and the seatbelt sign will turn off. That double chime is one of the most reassuring sounds in aviation, even though most passengers don't realize what it means. It's the captain telling the cabin crew that the aircraft has reached a safe cruising altitude. The worst part of the flight is over, and the cabin is now safe to move around in. Cabin crew use this signal to start the food and drink service. The same chime, played in reverse, signals the start of descent. According to the FAA, most commercial flight incidents happen during takeoff and the first 10,000 feet of climb. Once the seatbelt sign turns off and you hear that double chime, the aircraft has statistically passed the highest risk phase of the flight. The hiss during descent. As the aircraft begins descent from cruising altitude, you'll often hear a continuous hissing sound that gets louder over several minutes. That's the cabin pressurization system slowly equalizing the cabin pressure with the outside atmosphere. At cruise, the cabin is pressurized to feel like 8,000 feet of elevation. As the aircraft descends, that pressure has to gradually match the actual altitude outside. The outflow valve at the back of the fuselage opens partially to bleed pressure out, and that bleeding creates the hiss. The reason this is gradual is your ears. If the cabin depressurized instantly, the pressure change would rupture eardrums. The hiss is the system protecting you, slowly. The faint popping you feel in your ears during this period is your eustachian tubes adjusting to match. The thunk on landing. The thunk on landing is one of the most misinterpreted sounds in aviation. A few minutes before landing, you'll hear another heavy clunk and grinding from below. That's the landing gear extending again. Then on touchdown, there's a sharp, hard impact sound, and the aircraft seems to slam onto the runway. Passengers often think the pilot landed badly. They didn't. Modern airliners are designed to land firmly on purpose. A soft landing, where the wheels barely kiss the runway, is actually dangerous on wet or icy surfaces because the tires don't grip immediately. Pilots are trained to put the aircraft down with positive contact, especially on short runways. According to commercial pilot training standards, a normal touchdown rate is between 60 and 240 feet per minute of vertical speed at impact. That sounds rough, but it's by design. The roaring whine after landing. Right after the wheels touch down, you'll hear a sudden, intense roar from the engines, louder than even takeoff thrust. That's the thrust reversers deploying. Reversers redirect engine thrust forward instead of backward, slowing the aircraft using engine power instead of just brakes. Look at the engines on landing, and you'll see panels at the back of the engine cowling open up, exposing internal blocker doors that flip into the exhaust stream. Pilots typically apply reverse thrust for 10 to 15 seconds before transitioning back to wheel braking. The reason it sounds so violent is that the engines are at high power, but the energy is being thrown forward against the aircraft's motion. Without reverse thrust, Airliners would need at least 30% more runway to stop. That terrifying roar after landing is actually the system saving the flight from overrunning the runway. And that's every major sound you'll hear on a commercial flight, from the boarding chime to the reverse thrust roar. Which sound used to scare you the most? Drop it in the comments. Now here's the thing. Every sound you just learned about is a sound passengers can hear. But there's an entire layer of sound happening in the cockpit that you'll never hear from your seat. Alarms, chimes, synthetic voices saying, "Pull up, pull up." Each one is designed to alert pilots to a specific danger, and ignoring any of them can end the flight. Which warning is the most urgent? Which one means the aircraft is seconds from disaster? And which one has been heard on the cockpit voice recorder of nearly every fatal commercial accident? That's exactly what we're covering next. Click the video on screen right now, and I'll see you there.